Hey y'all, welcome to Miss Clark's chemistry class. This lesson is going to be an overview over the metric system. Now, I know some of you missed this lesson in class this week, so I wanted to go ahead and record this lesson so you wouldn't miss out. First of all scientists are always going to use the metric system. Scientists use the metric system because it's based on powers of 10. Being that it's based on powers of 10 make the conversions much easier. Also, the metric system is built on base units. And you do have to know these common base units. Now, let me think about base units for a second. In the imperial system, the system that we use here in America, if we're thinking about distance, we're going to have 12 inches equaling 1 foot, or we could say we've got 3 foot in a yard. Now, I don't know how yard translates to miles, but I do know that 1 mile is 5,280 feet. Now, all of those are in distance, and all of those have different units. We've got inches and feet, and yards, and miles. They're all different. They don't relate to each other, except for they're all distance units, and we know that because we've kind of grown up with them. Let's look at these numbers, 12, 3, 5,280. There's no consistency here. This is the reason why using base units in the metric system is so helpful. So these base units, since we were talking about distance, let's start with distance. Distance's base unit is going to be meters. We would use lowercase m. And then if we were measuring volume, that base unit is going to be liter, capital L. If we're going to measure mass, that's going to be in grams. That's a lowercase g. If we were going to measure time, that base unit is seconds. No, we don't really consider seconds to be a part of the metric system, but it is the base unit for time. So in science, anytime you're describing a time, you're going to use seconds, and then you would use a metric prefix. We're going to get to those metric prefixes in just a second. The last base unit that I wanted to talk about is temperature. Now, these are not all of the base units. These are just the most common base units and the one that you have to know. As we go through the course, we may add one or two to this. Temperature, in chemistry, we do like to use Kelvin. The Kelvin scale, that's capital K. The Kelvin scale, that's the scale that absolute zero comes from, where all motion stops. And the main reason why scientists like this scale is because there are no numbers beyond zero, so there are no negatives. The metric measurement for temperature is Celsius. Oh, I should have learned how to spell Celsius before right now. I never can remember if there's a C there or an S. Please forgive me, y'all. Celsius, that's degrees Celsius. We know that Celsius is the metric system because the freezing point is at 0, the boiling point is at 100. That's a power of 10. Okay, so here are these base units. What makes the metric system so usable is that we're just going to add prefixes to change their value. So we need to talk about those prefixes. Now, when I'm learning the prefixes, I use the mnemonic device, and I like to write it vertically. Let me teach you this mnemonic device. You might have already heard of some of it. If you've already heard about King Henry dying by drinking chocolate milk, then you are already halfway there. If you have not heard of King Henry dying by drinking chocolate milk, that's okay. So let's start at the beginning, my mnemonic device. So I'm going to write the words out for us first. The great, mighty King Henry died by drinking chocolate milk. Y'all, I'm running out of space. Under nice, pretty flowers. The great and mighty King Henry died by drinking chocolate milk under nice, pretty flowers. Now, mnemonic devices do you absolutely no good if you do not know what they stand for. So the T stands for tera. The G stands for giga. M stands for mega. These three are capitalized. King, kilo, not capitalized. Henry, hecto, again, not capitalized. Tera, giga, mega, only 3 capitalized. Died, that's deca. Deca, I'm hoping we've heard of that. I'm also hoping that we've heard of some of these other ones, especially like giga, mega, kilo. Maybe we've never heard of hecto. That one's actually not very common. So D is deca. B, that's where we're going to put our base unit. Remember we just said base units were things like grams, meters, liters. Let's just leave it there for right now. Okay, so now let's keep going. We're at drinking. This is deci. Now we're at chocolate, C, that's centi, milli. Now this U for under. Now really U stands for micro. The rest of those correlate first letter to first letter except for micro. But think about micro. We have already got capital letter M. We have already got lowercase m. So what are we going to do for micro? So micro really is this funky, like backwards U. It's actually the Greek letter for M. So it still does have M. It's just in the Greek letter form. Let's move on to nice. N, that's nano. P is pico. Some people call it pico. F is femto. Now I want to talk about these base units and give them some values. Let's start with the smaller ones. And I know they're smaller because they're under the base unit. The way this mnemonic device gives you these prefixes, it gives you from the biggest to the smallest. So we already know the order because the mnemonic device teaches us the order. I want to start by talking about the smallest units first. So deci. Deci is worth 10. If I were looking at a meter stick, in fact, in my classroom, I have a meter stick, and it is measured by decimeters. And there are 10 decimeters for every 1 meter. So deci has a value of 10. But I am going to use exponents. So I'm going to say 10 to the first. And I know you're like, Ms. Clark, 10 would be so much easier. Why do we need to think about exponents? I promise in a second you will understand. I promise. So 10 to the first, that's saying a 1 and 1 0, which is 10. Let's talk about how to write that conversion factor right quick. Now, that is not my main focus on this lesson. I have a lesson specifically for how to create these conversion factors. So this is the precursor. This is the prequel to that lesson. But I still want to mix it in conversion factors because that is where we're going. So here we would say, if we were talking about distance, we would say that 1 meter equals 10 decimeters, or 10 to the first. Centi, I think we've heard of centi. Centimeters, that's what we measure distance with in science most of the time. If you're in a lab and you're having to measure a distance, you're going to be measuring in centimeters. And we probably already recognize that there are 100 centimeters in a meter, plus centi. There are 100 years in a century, and there's 100 cents in a dollar. So we already have a little bit of experience with this prefix centi. But again, we're going to write 100 as an exponent, and so that's going to be 10 to the 2, which means a 1 and 2 zeros. Now this is going to be my last conversion factor to set up down here on the bottom, because that's not my main focus. But I just want to show you that 1 meter equals 100 centimeters. We are relating these prefixes back up to the base unit. All of these values only mean something when you're comparing it to the base unit. Okay, let's keep going. We're to milli, millimeters, milliliters. Anytime we're in lab and we're measuring volume with a graduated cylinder, we're measuring in milliliters. So we've heard of milli before. Milli means 1,000, but we're going to write that as 10 to the 3. Micrometers, we could use that unit to measure anything that we would look under the microscope for. So for example, a big cell like bacteria, if we were going to measure the length of a bacteria, we might would use micrometers. Micro means there's a million. A million. Now we are not going to want to write all those zeros every single time we need to convert. This is where these exponents start to come in handy. And a million is a 1 with 6 zeros. Let's go to nano. Nano is a billion. That's 1 with 9 zeros. A nanometer. We measure the wavelength of light waves in nanometer. In fact, pretty soon we're going to be measuring light waves and we'll be using nanometers. Let's go to pico. Pico, this is a trillion. So we've got 12 zeros. Femto, that's a quadrillion with 15 zeros. These two super small prefixes, these are for measuring the very smallest things on Earth, atoms. If I wanted to measure the distance between 2 bonded oxygens, I'm going to measure that in picometers or femtometers. If I wanted to measure the distance between the nucleus and electrons, these tiny subatomic things is what we're going to use these smallest 2 units for. Okay, so these are the smallest ones. All of these, I keep saying small because I want you to realize that all of these below the base unit, they're smaller than the base unit. So when we relate them back up to the base unit, we say that the base unit has a 1 because the base unit is big. And I think it's much easier to think about one giant unit and how many tiny units would fit inside of it, instead of thinking of one tiny unit and what's the fraction of that big unit. I don't like thinking in fractions and negatives and decimals. So we're going to think about the smaller units being smaller than the base unit. So now let's go up and talk about those ones that are bigger than the base unit. We've got deca. Deca, even though it has a K in there, we should have experience with deca. We know there are 10 years in a decade. So again, 10. But again, I'm going to write it as an exponent. Let me write a conversion factor for you. I'm going to do 2 conversion factors on the top again. Deca, if I were to take 10 meter sticks and glue them all together and make one long stick, that's a decameter. So 1 decameter is DKM, deca is DK. 1 decameter is worth 10 meters. See what I just did there? Since deca is bigger than the base, it got the 1. But we still needed to use this value here, so we gave that to the base unit. 1 big decameter has 10 meters in it. So as you go up, we're still comparing it to the base unit, but now the base unit's smaller. And we are always going to give the unit that is bigger the 1. I'm going to continue that on the next lesson. I just wanted to give you a little bit of taste, and I wanted you to start thinking about that, because this is the process that confuses most students. If you're going to struggle at converting metric units using dimensional analysis, I know I just said a hateful word, dimensional analysis. That's our whole point here. We've got to be able to convert metric units using dimensional analysis. The thing is you've got to create your own conversion factors. I'm not giving them to you. So you have to memorize all of this stuff that we're going over. That's why I'm trying to give you a mnemonic device. That's why I'm trying to create this pattern with exponents that I've not brought to your attention yet. It's all because we're building towards being able to do dimensional analysis to convert metric units. So keep going. There is 2 more lessons in this series. Let's get back to hecto. I kind of took a sidetrack, didn't I? Hecto, that's 100. If we were to take 100 meter sticks, glue them together, hold it up, that is a hectometer. Hectometers. Maybe I might measure the length of my street with a hectometer. Again, let's do 1 more conversion factor. So the hectometer, that's 100 meter sticks glued together. That's the biggest unit. So 1 hectometer would equal 100 meters. I'm hoping that makes sense, how at the bottom we gave the base unit a 1 because the base unit was big. But up here, we're giving the prefix a 1 because they're bigger, and we're using the value with the base unit. Let me keep going. Kilo. Kilo, we should probably have some experience with kilo. We know about kilometers, kilograms, and kilo means 1,000, 10 to the 3. When we're thinking about measuring things with kilometers, we're thinking about miles. Anything that we would measure using miles, we would use kilometers for. Let's go to mega. Mega means million. Mega Millions makes me think of the lottery, which I never play because I'm too cheap. Million, 10 to the 6. Now I'm hoping that you're recognizing these top 3 units, mega, giga, tera. I feel like most of the time when you recognize those, it's from technology. You sure do recognize it when you pick up your phone and you try to take a picture? Nope, you got too much stuff, and you got to get rid of some stuff to clear up some memory. And that memory is measured in megabytes or kilobytes. And so really and truly, bytes, that's another base unit. Giga. Giga is a billion, 10 to the 9. And tera is a trillion, 10 to the 12. These units are so big. I'm thinking a megameter would measure like, a million meters. Maybe around the circumference of the earth, like around the equator we could measure in megameters. Gigameters, we're measuring like from the earth to the sun, from the earth to Jupiter, within our galaxy, but within our galaxy. Tera, that would be maybe for galaxy to galaxy, from star to star. It is very difficult for me to wrap my brain around units that are so big and ginormous. Now let me show you my little shortcut for memorizing this. Now, of course, you're just going to have to memorize those prefixes and how they relate to the great and mighty King Henry. You know what? Let me go back really quickly and label that these are bigger than the base unit. I know I said that a whole lot, but we never did label it. Every single time I sit down to work metric unit conversions, yeah, I know, that sounded really nerdy, didn't it? I'm normally just converting metric units when I'm making your answer key, but still, I have all these memorized and I can recall them at will, but I still create this little cheat sheet on everything that I do so I can have a quick reference. This is the cheat sheet that I hope you will be able to utilize. I think it makes things much, much easier. So on your paper, before you start working, I'm going to label the great and mighty King Henry. So we've got the great, mighty King Henry died by drinking chocolate milk under nice, pretty flowers. Now, base unit, we did not talk about the value of the base unit because that's like the root, the base. And if the base is like the root, then these are definitely your prefixes. So when you put those together, you'll have things like teragrams, milligrams. You're going to have the prefix and the root. Okay, I jumped ahead a little bit. Base. I am going to give base the value of 0 because it's really just a placeholder. And then I'm noticing I'm just looking at my exponents. I am just looking at my exponents. And I realize that my exponents make a pattern. 1, 2, 3, 6, 9, 12. I counted by ones to 3, and then once I got to 3, I started counting by 3. That pattern stays true at the bottom. 1, 2, 3, 6, 9, 12, except for I have one more prefix down here, but it stays the same pattern, 15. Now, I don't want to go too much further because my next lesson covers from here on out trying to create conversion factors, and then my next lesson, the third lesson, you're actually using those conversion factors to solve with dimensional analysis. So I hope this helped to give you an overview of the metric system, base units, the prefixes that I require my students in class to memorize, and their values, and a little sneak peek on trying to set up conversion factors. Don't forget to continue on with conversion factors. Until next time, bye y'all.